Today we will study about Gauss Jordan method. Now Gauss Jordan method is similar to your Gauss elimination method. Now let's take a look at the working rule of a Gauss Jordan method. Now here we can assume the following as a system of equations. Now the equations are given here: a1 x1 plus b1 y1 plus c1 z is equal to d1, a2 x plus b2 y plus c2 z is equal to d2, and a3 x plus b3 y plus c3 z is equal to d3. Now as we have done in the Gauss elimination method, here also we can convert the system of equations into matrix form, and this can be written as Ax is equal to b. So from the system of equation you can find your a, you can find your x, and you can also find your b. And finally your aim is to solve x for x, y and z. Now regarding the working rule, the first step is you have to convert the system of your equation into the form Ax is equal to b, and I hope you all know how to convert this. We have discussed this in the Gauss elimination method. Then as usual you have to find out the augmented matrix, that is C is equal to AB. This is one of the example for the augmented matrix, where I have written the elements of A over here and then the elements of B. Now this difference is coming in the step 3, that is the difference between Gauss elimination and Gauss Jordan method is that after you convert your AB into the augmented matrix, what you have to do is the diagonal elements of C over here, which I have highlighted in red, it should be converted into unity. That is, this diagonal element should be converted into 1, 1 and 1, and all the other elements, that is which is marked in blue, should be 0. Okay, so you have to transform the matrix C in such a way that the diagonal element should be unity, and the elements beneath the diagonal elements and above the diagonal elements, now for example in this case where I have marked blue, it should be converted into zeros, whereas in Gauss elimination method you should only consider the elements which is beneath the diagonal elements, and in that case it was like you have to convert those you have to form an upper triangular form, and the elements beneath the diagonal elements were converted into 0. Okay, so that was the difference. That is the difference between Gauss elimination and Gauss Jordan method. So after converting the matrix C into what we have said earlier, we can form new equations using back substitution, and we can find the answers for x, y and z. Now step 4 and step 5 will be more clear when we do a problem. So let's move on to a problem. Now the problem given to you is this, that is 6x minus y plus z is equal to 13, x plus y plus z is equal to 9, 10x plus y minus z is equal to 19, and you have to find x, y and z using Gauss Jordan method. So our first aim is to find convert this system into the system of Ax equal to b. So that I have already done, and then I found out the augmented matrix, that is C is equal to AB. So here I have written all the A's, and here it is all the D's. Okay, fine, I hope this is clear with you. Now I'm going to change all the elements beneath and above the diagonal elements into 0. So for that I am just applying two operations in the first step. So my two operations are R2 is equal to R2 minus 6 R1, and R3 is equal to R3 minus 10 R1. So for applying these two operations, I just made the two elements over here as 0, but that is not enough. Now what I'm going to do is I'm going to interchange this R2 and R3. So here in this step our R3 is 0, minus 9, minus 11 and minus 71, and here it is 0, -7, -5, and -41. And okay, now when I interchange it, before interchanging, what I'm going to do is I'm going to apply this also. R3 is equal to R3 minus R2. Okay, then I'm going to interchange it, and that is how you get this answer. That is 0, -2, -6, -30, 0, -7, -5, -41. It's not necessary that you have to interchange it. So I'm doing this only for my convenience so that I reach the answer a bit earlier. Okay, without much iterations. Now after that, what I'm going to do is I'm going to, so before, here you can see a -2, this element. So see, one of our conditions was that the diagonal elements should be unity. So I'm going to convert this -2 into 1. So I'm going to divide the whole R2 by 2 in the next step. R2 by not simply 2, it's -2, so that I get this as my +1. And yeah, that is it. Then my next step is R3. R3 plus R3 is equal to R3 plus 7 R2, and here this -7 is converted into 0. Okay, now so beneath the elements, beneath the diagonal elements are now 0. So in the next step, what I'm going to do is I'm going to divide this by 16 so that I get a 1 over here. So all my diagonal elements and the elements beneath the diagonal elements are 0. Now I have to concentrate over here, the elements above the diagonal elements. Okay, now I have to convert this 1, 1 and 3 into 0. So in my next step, what I'm going to do is I'm going to apply two operations over here first in one shot. So R2 is equal to R2 minus 3 R3, and R1 is equal to R1 minus R3. So applying that, I get two elements over here as 0. Then this one, that is this element should be made into 0. For that, I'm going to apply another operation. R1 is equal to R1 minus R2, and I successfully got this also as 0. Now as you can see, all my conditions are satisfied. The upper elements are 0, that is the elements above the diagonal elements are 0, and the elements below the diagonal elements are also 0. The diagonal elements are unity. Now it is easy for me to arrive at a conclusion that x here is equal to 2, y equal to 3, and z is equal to 4. I hope you understood the working rule and the problem regarding Gauss Jordan method. Thank you.